Okay, class 10, good afternoon. Good. So, you know that we are discussing the chapter force, right? So, what was discussed yesterday? Could you remember? Good. Special features are next. Gravity. Numerical problems also, right? Okay, students, what is the formula that we have? The formula we have got from gravity. Could you remember? Gravity. I square. That's right. That is of gravity. And gravitation is F equals to G m1 m2 by d square. Okay. And next thing, what are the effects of gravity? Yeah. Ice occur. Okay. So those were discussed yesterday. Okay, students. In today's class, we will be discussing some new headings. I have already shared in our messenger group. Did you see it? Acceleration due to gravity. Okay. Students, let me share the screen and we will be discussing about it. Are you ready? Okay, good. So this is class 10. I'm going to share the screen. Class 10 PDF. I think this one PDF. What is here? So let me share. Yes. Can you see in the screen? So acceleration due to gravity. Students, what happens if we go at a certain height and drop a ball? The ball goes towards the surface of the earth, right? Isn't it? It's because the earth has pulling force, which we call it gravity. Because of that, the object or the ball falls down. And if somebody jumps from the flying airplane, he also falls down towards the surface of the earth, right? It's because of gravity of earth. So, when any object falls down from certain height in any heavenly body, at that time its velocity increases. Velocity increases. So when there is increase in velocity, there is production of acceleration. When there is increase in velocity, what is produced? Acceleration is produced. And that acceleration is produced because of gravity of the heavenly body. Because of gravity of the heavenly body. That's why that acceleration which is produced due to gravity of the heavenly body is called acceleration due to gravity. Okay, students, look at the figure. Figure 1.12. It is shown. An object is dropped from certain height. At the beginning, its velocity is 0. After 1 second, its velocity becomes 9.8 meter per second. After 2 seconds, 19.6 meter per second. After 3 seconds, 29.4 meter per second, etc. So in every second, the velocity increases at the rate of 9.8 meter per second. In case of Earth, so there is change in velocity of 9.8 meter per second in every second in the Earth. That's why the acceleration due to gravity of the Earth is 9.8 meter per second square. 9.8 meter per second square. Students, what happens if we drop any object from certain height on the moon? In that case also, there is change in velocity, increase in velocity. But the increase in velocity is not as same as that of the Earth. Why? Because the gravity of the moon is 6 times less than that of the Earth. That's why the gravity of the moon is 6 times less than that of the Earth on the moon. So, the change in velocity is also 6 times less. I mean to say, if any object is dropped from certain height on the moon, its velocity increases at the rate of 1.67, mark this thing, 1.67 meter per second in every second. Okay, students. Now, at first let's define acceleration due to gravity. How to define it? Definition is as follows. The acceleration produced in a freely falling body due to the force of gravity of the earth or gravity of heavenly body. Acceleration is produced automatically because of gravity of heavenly body, but it is mentioned here earth means that is the acceleration due to gravity of earth. And which symbol is used to denote acceleration due to gravity? Small g, and SI unit is meter per second square. It is marked there ms minus 2 means meter per second square. And students, if we talk about the earth, yesterday also I said the earth is not perfectly spherical, so the value of small g is also not same in all places, but the average value is taken, which is 9.8 meter per second square. 9.8 meter per second square. Can you hear? Students, are you hearing or not?
Yes, sir. Yes, sir.
Is my sound clear? Okay. Okay, students. Now listen. So, the acceleration due to gravity on the earth is taken as 9.8 meter per second square, but it is not fixed. If you go in polar region, the value will be more. How much is it? 9.83. Remember, 9.83 meter per second square at polar region and 9.78 meter per second square in equatorial region. So you have to keep in mind the value of small g is more at polar region and less at equatorial region. Alright, students. Actually, the value of g is more at polar region because the polar radius is shorter, and the equatorial radius is longer. Polar radius is shorter, equatorial radius is longer. And again you may say that why it's listen, small g is inversely proportional to radius. More radius, less small g, less radius, more small g. That is inversely proportional. Okay? So students, now let's go to next slide. What does it say? it says that falling bodies and acceleration due to gravity. What is next heading? Falling bodies and acceleration due to gravity. Yeah, okay, students. So one diagram is given there. Can you see what is there?
Yes, sir.
Leaning Tower of Pisa. Leaning Tower of Pisa. Right? Pisa. Actually, this leaning we had got earlier one tower. Could you remember? It was Bhimsen Tower. Dharahara. Yeah, nowadays, yeah, it was collapsed during the earthquake of 2072. Yeah, 2072. It's under construction nowadays. I found that it was nearly how much percent completed? 15 or 20% completed. Okay. So Leaning Tower Pisa, it is in Italy. Okay. So why this diagram is given? You know, this diagram is given because one famous scientist, Galileo Galilei, performed experiment on this tower in 1590 AD. In which year? 1590 AD. Okay, so before Galileo, it was thought that the speed with which a body falls to the ground depends on its mass. It means before him, what it was said, bigger body falls with more speed, smaller body falls with less speed. Like higher the mass, more speedily it falls to the ground. Lower the mass, less speedily it falls to the ground. So it was said by Aristotle. Who said this? Aristotle. He was a famous Greek scientist. But Aristotle's saying was made wrong. It was proved by Galileo Galilei. So what did Galileo Galilei do? You know, he climbed at the top of this Leaning Tower of Pisa and he called some of the people and asked them to check the result. He took two different stones. One stone with more mass, another stone with less mass. Then he dropped simultaneously together and both of the stones reached on the ground at the same time. So Aristotle's idea was flop afterwards. Super duper fraud. But one thing remember, so it doesn't matter whether heavier or lighter body, when they are dropped from certain height, their speed remains same. But one question we have to remember, one thing we have to keep in mind, that if there is air, at that time a heavy object will fall faster, lighter object will fall slower. Do you know why? Because the air pushes lighter object with more force. Lighter is there, isn't it? You have already played that paper airplane, right? Does paper airplane fly for some time or not?
Yes, sir.
Definitely. But if you take one stone and throw, will it fly? It doesn't fly like that because stone has more mass, paper airplane has less mass. But one thing keep in mind, if there is no air resistance, at that time stone as well as a paper airplane, they will fall together. We have already studied that there is no atmosphere in the moon. There is no atmosphere in the moon. If, I'm saying here, if an elephant and a small bird, remember, an elephant and a small bird are dropped simultaneously from certain height, then what will happen? Can you say? Both the things, the elephant as well as the bird, will reach on the ground together. But in earth, it's not possible because there is air resistance. Air resists, air blocks those bodies. But on the moon, there is nothing, so they will fall together. That's why, in the absence of any resistance, any blockage, whether heavier body or lighter body, they all fall together. It was proved by Galileo in 1590 AD. 1590 AD. So students, next thing you have to remember, in the absence of air resistance, every falling body has equal acceleration due to gravity. Means equal acceleration. So keep this thing in mind. Here is one activity. What does the activity say? Take two paper sheets of equal size, squeeze one of the paper into a small paper ball and another remains as unfolded. No need to fold it. Drop both of them for the same height and at the same time. Which one paper ball or unfolded paper sheet will reach the ground faster? Can you say? Folded or squeeze will fall faster because for folded, less air resistance is applied. For unfolded, more air resistance is applied. Right? Isn't it? But students, if the same experiment is done on the surface of moon, squeeze paper and unfolded paper are dropped from certain height, at that time what will happen? Can you say? Both will drop at the same time. So here we have to keep in mind who is the villain? Air resistance, right? Air resistance is the villain, means it decreases the speed of falling bodies. Students, here is another experiment. So what is given here? We have to take two stones, one with less mass and another more mass. So if we drop them from certain height, then which one will reach the ground faster? Which one? No, stone, big stone and small stone. Big stone, right? Because for small stone, there is little bit more air resistance. Now students, this type of things we have to remember. It means the acceleration of falling bodies is equal when there is no air resistance or when there is no any blockage. Okay? My dear students, are you together with me or you are behind me? What do you think? Are you together with me?
Yes, sir.
Now we will be discussing next thing. What is that? Feather and coin experiment. What's next? Feather and coin experiment. Okay, my dear students, just look at the diagram. What can you see there? In figure 1.14, in figure A, there is air. Yeah, in figure B, there is no air. It means in figure A, there is resistance. In figure B, there is no resistance. Okay? Yes. And listen, who did this experiment? Sir Isaac Newton. Absolutely correct. Sir Isaac Newton. So, Sir Isaac Newton took one vessel and two objects. One is feather, another coin. Obviously, we know that feather is lighter and coin is heavier. And this experiment was done for 2 times. How many times was it done? 2 times. At first, coin and feather, they were kept at the one end of the vessel. There was presence of air. There was presence of air, and it was inverted. When it was inverted, which one reached on the surface, means at the bottom first? Coin reached at the bottom first, right? And feather reached slowly, because there was presence of resistance, and the resistance was of air. Air did not let the feather to fall down faster. But again, in next time, what was done? All the air was pumped. All the air was taken out from the tube or vessel. And when coin and feather were dropped at that time, both of them reached at the bottom together. So, what does it show? It shows that in the absence of air resistance, all the bodies fall at the same rate. In the absence of air resistance, the bodies possess equal speed, equal acceleration. Okay, students of class 10. Now, we will be discussing that the conclusion of feather and coin experiment. What is that? Conclusion of feather and coin experiment. What is the conclusion? Will you read? Acceleration due to gravity of freely falling bodies, whatever their masses, is the same in the absence of air resistance. If there is no air resistance, whether massive body or micro body or big body or small body, all of them fall with same speed, same acceleration. Okay? So, but next thing, if there is presence of air resistance at that time, the body with more mass falls faster, less mass falls slower. Is that clear or not? Now students, next thing we are discussing here, sometimes Nepal Army launches some programs. During Ghori Jatra, you might have noticed some people, they fall down using parachute. Have you seen? So can they land on the earth safely or not? Definitely they land on the earth safely, because the parachute, when the person falls with parachute or jumps down with parachute, at that time the parachute opens and the speed decreases. The parachute gets air resistance on the earth. Next thing, if same person goes on the moon and lands with parachute, will he land safely over there? No. Person cannot land safely. Why? Because the parachute does not open. Why it doesn't open? Because there is no air resistance. If there is no air resistance, then the person falls with more speed and will have accident. So it says here, parachute has no use on the moon because the parachute falls freely with acceleration due to gravity on the moon due to the absence of air resistance. And this was proved after doing the experiment of the astronauts who reached on the moon using the spacecraft Apollo 12. Apollo 12. So remember, in which spaceship Neil Armstrong reached on the moon? Do you have any idea? Apollo is right, Apollo 11. Neil Armstrong, Michael Collins, and Edwin Aldrin. They were the crew members of Apollo 11. But afterwards, the astronauts who reached on the moon in Apollo 12, they performed experiments like coin and feather experiment, and it was proved. Students, now we have got 10 more minutes. Afterwards, don't forget to send me the friend request. I will just guide you. Students, here is one activity. What is here? Let me read once. Take a measuring tape, a piece of stone, and a sheet of tin. Place the sheet of tin on the ground below from the height of the school's building, which will produce sound while the falling stone hits it. Measure the height of the building from its rooftop to the ground using a measuring tape. Take a stone in one hand and a stopwatch in another hand. Drop the stone and start the stopwatch to record the falling time of the stone. At the same time, record the time period until you listen to the sound produced while the stone hits the tin. Repeat this experiment 4 times and find out the average acceleration due to gravity using the observation table. Compare the average value of acceleration due to gravity with 9.8 meter per second square. Actually, we have studied the average value of acceleration due to gravity on the earth is 9.8 meter per second square, but the activity says you need to do experiment yourself, taking one stone and mixing measuring tape, its height and stopwatch, and doing it 3-4 times, right? So observation table is given here. Alright students, so in today's class, the last portion which we are going to discuss is, will you read the heading? The relation of acceleration due to gravity with the Earth's radius. It means now we are going to derive third formula. The first formula was F equals to G m1 m2 by d square, right? Second formula, F equals to capital G, capital M, small m by r square. Yes or no? Now, the third formula we are going to derive, that is of small g. What is small g? Acceleration due to gravity. Sometimes question can be asked, derive the following. So you have to derive. Okay, students? So can you see figure number 1.15? What is given there? One heavenly body with mass capital M. Another small body on the surface with mass small m. And capital R, that is the radius of heavenly body. So this must be practiced. Listen now. Let capital M be the mass of the earth and capital R its radius. Then the force of attraction on a body of mass M on its surface is as shown in the figure. Diagram is given. Diagram must be drawn. According to Newton's law of gravitation, the force of attraction between them is F equals to capital G, capital M, small m by r square. Equation 1. And my dear students, you know the formula to calculate weight. F equals to m times g. That is equation 2. Equation 1 is F equals to capital G capital M by R square. Second equation is F equals to mg. So when we combine these two equations, what do we get there? mg equals to gmm by R square. So left side m and right side m cancel. What formula we have got? G equals to gm by R square. M means mass of the heavenly body. This is the formula to calculate acceleration due to gravity. So next thing we have to remember, the value of g and value of m are constant. Then g inversely proportional to radius of the earth. Earlier also I said, when the radius decreases, value of g increases. When the radius decreases, value of g increases. From the center of the earth, the value of g means r is less at polar region. So value of g is more at pole, that is 9.83 meter per second square. How much? 9.83 meter per second square. And at equatorial region, radius is longer, the value of g is shorter, that is 9.78 meter per second square. So finally, what can we say? The acceleration due to gravity of the earth is inversely proportional to the square of its radius. Let me tell one example. My mass is 60 kg. So where will be my weight more? At polar region or equatorial region? What do you think? At polar region, because the value of g is more, weight also will be more. Okay, students. So let me see. Saraj is ready. Sujina is there. Pratik is there. Good. Next, new sile trader. Also, reconnecting to audio. Who is there? Sujal is there. It's good. And Beaver Sava is there. Oh, Prachanda is also there. New Prachanda came here, right? Oh, Beaver Sava. 911 Shreya and Vinay and Vivek Saha and reconnecting. Means I think Barsar Limbu. Chris Sai. Okay, no problem. Students, listen now. What do we do? I have explained. Now I will share the screen for you 10 minutes. How many minutes? 10 minutes. So, and afterwards I will give you some work to do. Now, so let me give you some time for study and then I can give you some work. Okay? I will share the screen, no problem. I think after 3 minutes, it may be disconnected, but again, join. Don't forget, okay? Good, good. Let me share the screen. I'm sharing the screen. So it is of class 10. Class 10. So I will just move it slowly. So please read it once, because this reading is also important. Yeah, so I will just keep on changing the slides for some time. Later on work will be given. Okay, students? Okay, please go on reading. Okay, students, let me see what are my favorite students doing. Okay, Ojas is being busy to do something. Now next person who is here. Listening, good. So voice is clear, isn't it?
Yes, sir. Now very clear.
Very clear. Okay. Okay, good. Very fine. So here are 4. Okay, Ojas, what did you write till now? Did you write something or not? Please convey in the group. We can hear it.
Yes, sir. Please.
Yeah, today's one. Come on.
Yes, sir.
Okay, come on. You just read. Afterwards, Sujina, you be ready, eh?
Okay, sir.
Okay, so I'll just continue.
Acceleration due to gravity.
Okay.
Acceleration due to gravity is defined as the acceleration produced in a freely falling body due to the force of gravity of the Earth,
Okay.
and the acceleration due to gravity near the surface of the Earth is about 9.8 meter per second square.
Good.
And then after air resistance as well as gravity determines the rate at which a body falls towards the Earth.
Good.
Acceleration due to gravity of freely falling bodies,
Okay.
whatever their masses, is the same in the absence of air resistance.
Yeah. That is the conclusion of coin and feather experiment. Okay. Conclusion of and okay. Now, yeah, Sujina, your turn. What did you write? Come on. Now Sujina's turn. Sujina, first unmute your audio. Audio is muted. Okay, please read now.
Acceleration due to gravity. When a body is released from a height, it freely falls towards the surface of the Earth due to the gravity of the Earth.
Okay.
The acceleration due to gravity near the surface of the Earth is about 9.8 meter per second square.
All right.
Galileo did this experiment to demonstrate it in 1590 AD of falling bodies and acceleration due to gravity.
Good.
Sir Isaac Newton put a coin and feather experiment to confirm that acceleration due to gravity of freely falling bodies, whatever their masses, is the same in the absence of air resistance.
Okay.
The acceleration due to gravity of the Earth is also inversely proportional to the square of its radius.
Radius.
The acceleration due to gravity in all the falling bodies will be same at the given place if there is no air
Air
resistance.
resistance. Good. So because of air resistance, speed of falling body decreases. So when the speed of falling body decreases, acceleration due to gravity also decreases. Is that clear? Okay, students. Now it's the time to do some work. You have got your pen and paper. Please take out. I will give you questions. You have to do it. Okay?
Yes, sir.
Yeah, because what we have studied today, so based on that, work will be given. Let me check it out. What is here? All right. Question number one. Question number one. Define acceleration due to gravity. Define acceleration due to gravity.
Define.
Acceleration due to gravity. Writes its value on the earth. Write its value on the earth. Write its value on the earth. Okay, this question answer you can do yourself. Let me tell you next question and next its answer. I will tell the question also, answer also. Okay. Question number 2. Write down the value of acceleration due to gravity on the earth is 9.8 meter per second square. The value of acceleration due to gravity on the earth is 9.8 meter per second square. What does it mean? What does it mean? Okay, write down the answer. The value of acceleration due to gravity on the earth is 9.8 meter per second square. Means when a body is dropped from a certain height, the velocity changes at the rate of 9.8 meter per second in each second. 9.8 meter per second in every second, you can write in every second. Next question. When did Galileo Galilei perform the experiment to show acceleration due to gravity of falling bodies? Gravity of bodies of falling bodies. Next question. What is the conclusion of coin and feather experiment? What is the conclusion of coin and feather experiment? Feather experiment. That is acceleration due to gravity of freely falling bodies, whatever their massage, is the same in the absence of air resistance. Okay. Why is it dangerous to use parachute on the moon? Or why is it dangerous to fall with parachute on the moon? And last number is fall with parachute on the moon. Fall with parachute on the moon. And last question. Derive small g equals to gm by r square. Small g equals to capital G capital M by r square. So did you write these questions? How many questions did you get today? 6 questions? In that derive, you have to draw the diagram. Is there a diagram or not?
Yes, sir.
So the diagram must be drawn. Okay, students. So today's class is over. And next day we will meet with new topics and new energy. Okay?
Thank you, sir.
Okay, till then, thank you and bye-bye. Have a nice time.
Bye, sir.
Yeah.
Okay, see you, sir.
Okay.